Good afternoon, everyone. How's our Friday afternoon been today? Good? Everyone's good? Everyone wonderful? Perfect. Now, last lesson I said that today's class is going to be very exciting. And why was that? Yes, George? Yes, because today we are jumping into a new topic. And I love new topics. I love starting something different, starting from knowing nothing to just filling our brains with new ideas and theories and knowledge. So, I'm not going to give too much away, but today we are going to be looking at the states of matter, the three major states of matter. So, I'm going to begin just by, some of you may know about this, some of you may have learnt bits and pieces before, so you can help us along with our discussion, because we're going to have a bit of a class discussion to begin with before we jump into our prac. So, first question, what is this? Yeah? Come on, this is easy. What is it? Yeah, it's an ice cube. An ice cube. So, this piece of matter, everything's a piece of matter. This pen is matter. My hair is matter. Your water bottles are matter. This piece of matter is an ice cube. Now, it is cold, but I'm getting through it. Apart from cold, how can we describe this piece of ice? What does it look like? It's a square. It's got a shape. It's got a shape. It has a size. Can I bend it? No. It's firm. It's strong. What is it? Is it soft? No. Definitely not soft. It's a solid. Fantastic, Emily. It's a solid. So, this solid in my hand keeps its shape, has a set size, and so the molecules of this solid are very tightly packed, and that is what keeps their shape. Now, as we can see, the warmth of my hand is already making this ice cube melt. It's starting to slide up around my hand. So, it's starting to melt. Now, what would happen if I put this ice cube, this frozen piece of water, that's what it is, it's frozen water, that's how you make ice, this frozen piece of water into just your average room temperature tap water? What's going to happen eventually? Not instantly, but very soon. Yeah, Ben? Yeah, correct. It's going to melt. So, it won't happen instantly, but it will happen. So, if this ice from the frozen temperature is put into room temperature, it changes. It changes into a liquid. So, by cooling down, by adding heat to the ice cube, it transforms into this water. Now, describe for me, what is water? What does it look like? See me squishing it around? It has a size. We have a cup of water, for example. We have 250 mils of water, so it has its volume. Getting into maths now. It has its volume, but it doesn't really have a shape because it takes up the shape of the container. If I was to pour this into a jelly mold, it would take the shape of the jelly mold. If I was to pour it into a champagne flute, it would take the shape of the champagne flute. It changes depending on what container it's in. So that's how it's different to solid. It doesn't really have a set shape. Anyway, water. Tap water. It's not a food. What is it? You drink it. What is it? Yes, Grace. It's a liquid. So liquids, they flow around. Their molecules are obviously, what are their molecules like? Are they as tightly packed as ice? No. They're a bit more spread out, but only to the extent of the shape of the container it's in. Now, if I was to heat this water to boiling point, what would happen? Your mum is making pasta, she puts the pot of water on the boil. What's happening? Yes, Ben, it starts to bubble. But then what happens? What do we see? Okay, let's look at something I prepared earlier. This hot glass, what do we see up here? Steam, yes, exactly right. We have steam coming out of the boiling water. The vapor, the water vapor. So what is steam? What can we classify that as? Yes, Louise, it's a gas. So this steam that you can't really see it too well, sorry guys, but the steam, does it have a shape? No, it's going everywhere. We can't see where it's going. So it doesn't have a shape. Does it have a size? Is there a certain amount of steam? Can we measure it? No, it's just keeps evaporating into the air. So the gas molecules, what is their structure like? Yeah, they're completely more spread out than both the solid and the liquid. So that is our three states. Our solid, our liquid, which the ice cube is almost gone because of this change, and our gas. And using water is the perfect example. We've just seen straight there the ice cube changing into three states. So anyway, today we are going to explore another property of those three states, so of the solid, the liquid, and the gas. We're going to look at whether these can be compressed. So we are going to do it in groups on everything set up on your lab benches, and probably going to have 5 groups of 4 and a group of 5. We've got a bit of an uneven number today, so we have 3, if you've all got your worksheets, they're on your desk when you walked in. We have 3 mini pracs in our overall big prac, and it is so important that as we complete the prac we write down what we observe happening, and we also write down why we think that is happening. And that way we'll be able to come to some conclusions as a class together later on. So this little table down here we need to fill out as well. It's just an easy way to visually instantly look at yes or no whether that state of matter could be compressed or not. So anyway, let's get to it. Have fun. I'm going to be walking around making sure everyone's on track, and we'll get back together in about half an hour and discuss what we've seen. Alrighty, thank you.